Good afternoon, ladies and gentlemen. I'm Jessie Liu. Today, my speech will be focused on why we need the convergence of the network manager, controller, and analyzer for the network automation, and finally, towards to the autonomous driving network. Based on the TMF 5G monetization research, actually, there is 72% of the 5G potential growth requires the operating mode change. Because the network automation is one of the most important components, especially in the areas of the improving the customer experience, providing the end-to-end service automation, and also to speed up the time to market, and also the new technology introduction. But on the other hand, we also see that AI and machine learning will also play a very important role to empower the network automation into a new level. According to Huawei Global Industry Vision, it predicts by the year 2025, there will be 103 robots will work alongside every 10,000 employees in the manufacturing industry. And there is three particular working areas. The robots, in many use cases, the best choice. The first one is in the subdars environment, the dangers. Secondly, is the reputation, and third one is the high perception operations. Actually, nowadays, the on-duty work is still a critical duty for most of the operation and engineering teams to undertake in order to keep the network reliable and available. Actually, as well as saving time and increasing the productivity, and also freeing people up to concentrate more value-added and also creative works. The robots also have potentials to have the positive impact on reducing the work pressures and also the work injuries. So in the 5G area, we believe the network operations should and will evolve to an AI-assisted autonomous network. But then, what's the top drivers of the AI-assisted network automation introduction in the network? Based on the Analysys Mason's investigation, the top 4 drivers are: the first one is reducing the OPEX, and second one is improving the customer QoE, and the third one is to densify the network effectively, and the fourth is to support the increased end-to-end automation. And also, the survey would show that for the mobile network operator, now more than 50% of them still have very limited and little automation in their today's network operation. And many of them, they are expected to automate up to 50% of the process in the next 3 years. But actually, we are talking about the network automation years for years. What's the difference for this year? And here, I would like to take the Google's evolution of the automation to compare where we are and where we go. Actually, 30 years ago, there was no automation at all. The engineers was using the command line to access the devices and to configure the services or configure the devices. And then the EMS or AMS was introduced as a GUI-based, GUI-based tools and script-based tools. And that was entering the phase 2. That is an externally maintained system-specific automation. And then the OSS was introduced to share the automation across a multi-vendor environment and also a multi-engineers environment operations. So then we are entering the phase 3, which is externally maintained generic automation. But then the SDN was introduced, which was providing the open APIs for the OSS, orchestration, and applications to be able to programmable the network to provide more automations. And that is a very significant step from the phase 3 to phase 4, because that is the automation functionalities was shifted from the external maintained systems to an internal maintained systems. And in the ideal environment, actually, it's better we would not maintain any externalized automation system. So the phase 5 actually is the system doesn't need any automation. And then it means the network itself is self-organized and self-healing. And actually today, most of the network operations was still in the phase 2, between the phase 2 and the phase 4. And also, as mentioned before, from SDN is one of the technology is critical to moving from the phase 3 to phase 4, because today there is one of the biggest pain point for the OSS is the agility to introduce new technologies. And the reason is because the automation will end up being maintained separately from the core system and therefore suffers from the bit rot. And our thinking and suggestion is to make each of the network technology domain highly automated, and then to create the simplicity for the cross-domains orchestration. And Huawei was worked together with TMF and other partners together to define the framework of the autonomous network. It includes 3 layers, from the network resource layers, network service operation layers, and also the business service operation layers. And it's also including the 4 closed loops. And the network resource operation layers is mainly to providing the network capability as a service, and then to providing the abstracted RFS APIs towards the OSS or orchestration, and then to supporting the business innovation. And the key actually is to decoupling the dependencies between the services, business, and the network. And then we can get the both fast innovation in both sides. And also that it will require to consolidate the existing EMS SD controllers to a platform. And that was the platform have to cover the complexities within a single technology domains, which was able to realize the closed loop quickly and efficiently. But the reality in the field is most of the operators today still have silo systems, and which are the bottleneck. So across the life cycle of the network resource operations, there are still so many dozens or even thousands, even hundreds silo systems. So it's such as the NMS, EMS, planning tools, performance management systems, and the SDN NFA actually even create integration complexities to introduce the manual controllers again. So the inconsistent data modeling actually caused the high integration cost, and that will be difficulty for the closed loop design and operations. And the second challenge is the consistency, because the consistency for the network resources layers is very important to realize the real-time closed loop for the fast action and fast repairs. And this kind of specific automation systems have to be evolved and consolidated to support the future's autonomous driving network architecture. In general, we think the traditional NMS has to evolve from the GUI-based operators, statisticians, to teachers, masters, and decision makers. So actually, what we see is there is a platform is needed to consolidate, no matter it is network management, monitoring, controlling, or data analysis functionalities, have to be consistent to provide the scenario-based or workflow-based automation for the customer full life cycle operations. And also, it have to be providing an unified open API gateways to be easier to be consumer from the up-level or external systems to get the capability and the services from the network. And also, enhanced by the intent-based networking, it will be help to providing a more abstracted APIs to decoupling the business innovation and network innovation with each other. And thirdly is the AI and the big data is also very important technology to be taken into account. So from the perspective of the AI deployment location, more higher than more centralized, and the larger data volume and more strong capabilities for the cross-domain analysis, and the more suitable for the global policies training and inference. But if the deploy location is more closer and more lower to the network side, the specific analyze capabilities will be stronger and the real-time performance will be better. So what we think is to realize a final autonomous driving network is very important to adopt a network architecture with a hierarchical autonomy with vertical collaborations to achieve this target. And Huawei has released our new generation of network management and control systems. The iMaster NCE Network Cloud Engine that was mainly focused on the fixed broadband network, which was including the MPLS IP network, optical transport network, fixed access network, and also the data center network. And the iMaster MAE, the MBB automation engine, it will be mainly focused on the wireless network and the cloud core network. And both of them are adopted the platform-based approach to consolidate all these functionalities to providing the RFS APIs towards the up-level systems. But Rome was not built in one day. Actually, finally to reach a fully intelligent autonomous network, there is still a long journey. And actually, the automation have to deliver it case by case, process by process, domain by domain. And but benefit from the platform approach, actually we can delivering the use cases much faster than before. So here we can see we have shared some of the use cases in the automation and intelligence. In the wireless network side, we are helping to speed up the site deployment efficiency up to 50% for the 5G network deployment based on the workflow-based automation. And also provides the mass MIMO automatic tuning, which have to reach the faster adjustment with better performance. And also in the fixed access FTTH domains, we are also trying to reduce all of the unnecessary site visit for the ONT deployment and also for the ORT configurations. And also we're providing the PAM network, machine learning-based issue recognition capabilities to reach the faster troubleshooting within minutes. And also in the transport network, so in the IP areas, we are providing the policy-driven automations based on SRv6 and also realize the faster troubleshooting based on the real-time in-band flow-based telemetry capabilities for the mobile transport network. And also in the optical side, we are also providing the optical services, optical latencies as a services, and also realize optical CPEs plug and play for the enterprise customers. And also in the core network, actually we are providing the application batch replications across different multiple MEC sites efficiently, and also providing the 5G slicing automation and the SLA monitoring functionalities. And also in the most mature SDN areas in the data center network, actually the systems was gradually evolved to the intent-driven change automation systems, which have to reduce to improve the reliability and the robustity of the whole systems, and also providing the AI-assisted fast troubleshooting within 5 minutes in the data center network. And actually, due to the relatively low credit or confidence in the network intelligence in the field, actually today, most of the closed-loop design is still prefer to give suggestions rather than take actions directly. And here, I would like to share 3 of them. The first one I would like to share is in the data center network, and how to realize the change automation in the data center network. Actually, in the data center network, it's already automated for the virtual machines and containers. But the challenges is due to the dynamic changes, there is a centralized mistake. And I have one of our customers, they have more than 300 network changes per day for their container environment. And there is 60% of the failure was caused by the service changes. And the network verification is the foundation to realize network robustity and the reliability during this in this dynamic service change environment. And the IMAST NCE will collect the live network configurations, topology, resource as the input, and mathematical algorithms for the data modeling, and also for the formal verification algorithms are used to verify the services availability in the real time, and also to check the connectivity access metrics, and then to ensure the new configurations will not impact the existing services running on. And actually, for example, in the data center network, to adjusting and changing the more than 20,000 security policy is so actually it's a headache task. And by using this network verification functionalities, which can help to be automatically to check all of these ACL rules, new ACL policies will be impacted existing ACL, and also it will check all of the security policies have covers all the address ranges automatically. And the second use cases I would like to share is in the FTTH. That was for the intelligent ODN for diagnosis. The FTT PAM network actually is a multi-level splitting point to multi-point passive network. And many customers was annoying by averagely more than 30% of unproductive home visit or site visit, which to have to handling the customer complaints or locate the fault. And we have one of our customers, they have 250 customer complaints per day. And there is up to 60% of unnecessary site visit in the past. And by introducing the iMaster NCE solution, it was providing 3 key capabilities. The first one, The systems will be based on the real-time telemetry to have the 24 hours, minutes level 24 hours, 7 days, the customer journey replay, and then to help for the proactive maintenance and fast response for the customer complaints. And secondly, it's based on the ODN self-learning, machine learning algorithms to help to do the faster fault demarcation. And the third one is there is up to 8% of the remote fault can be automatically recognized based on the machine learning and the hardware supervised deep learning algorithms. And finally, actually, it helps customers to improve 25% of the troubleshooting efficiency, and also there is more than 20% of the home visit expected can be reduced. The last one I would like to share is about the wireless network for the 5G massive MIMO automatic intelligent tuning. Actually, massive MIMO is one of the most important technology for the 5G. And compared with the traditional antenna, massive MIMO devices support the 3D beamforming capabilities, which will help to significantly to improve the positioning accuracy of the systems, and also can concentrating their single strands on the specified directional areas and the specific user group. But the challenge is it's not possible just to use a set of initial parameters to reach this optimal coverage and to maximize the spectrum efficiencies for the massive MIMO. But the manual configurations is impossible for the massive MIMO because there is tens of thousands combinations of the parameters. And also, the coordinations between multiple cells is also a difficulty. So that is very important to have intelligent AI and machine learning enabled assisted algorithms to help to realize the dynamic adjustment of the massive MIMO configurations. And the iMaster MAE is the solution which was coordinated work with on the smart adaptive modulation and coding in the devices to realize this dynamic adjustment and to improve the configuration efficiency at the initial phases, and then to continuously to iteratively optimize the performance in the field. And based on our trial in China for the 5G network, the average performance can be improved 20% compared with the expert-driven manual or tools-based optimization. And also, the efficiency was greatly improved from the 30 days to the 10 days. Last, I'd like to give a very quick summary, and there is 3 key points for my speech. The first one is we suggest to select a network automation platform rather than a separate tools to have the better closed loop design and then to have the faster use case delivery. And secondly, is consider the AI and big data at the first stage. And especially for the network resource layers, it will require the device AI and network AI coordination to get the real-time closed loop. And the last one is providing the intent-based RFS APIs that will be the key to decoupling the network domains with the business domains and then to simplify the IT integration. And the Huawei iMaster NCE and MAE product is focused on the network automation and the intelligence and providing a platform to our customers. That's all for my speech. And thanks for listening and any questions. Okay, thank you for your time.